Once upon a time, there was a pirate who sailed to a tropical island that was experiencing summer. So, to go to the island, the pirate must found the island port. When the ship close to the island, the ship will use radar to detect nearest port, where the ship will stop later. So, guys, from this event, we can use the implementation of a transformation, especially translation. So, let's look at an example problem.
Radar, or radio detection and ranging on a ship, is very commonly used in shipping navigation. Radar utilizes electromagnetic waves to detect and measure the distance of an object around the ship. The coordinates of the ship are determined in kilometer units, which refer to certain center point. On the radar, it is detected that the port is in the ocean, with coordinate -1,0 on the ship radar, while the ship is in a position 5,3. If the ship want to anchor at the port, the translation that must be done by the ship is blah blah blah. From this problem, we have given on the radar, it is detect the port in the ocean with coordinate -1,0, while the ship in position 5,3. Also, the ask is the translation that must be done by the ship. Before we solve the problem, we will draw some illustration to make it easier for you understand the problem. We support the coordinate in the radar with Cartesian coordinate. Draw Cartesian coordinate with x-axis and y-axis, and then draw point that represent the position of the port. It is point -1,0, and then draw also a point that represent the position of the ship. It is point 5,3. Where we know the port usually on the edge of the island, translation that the ship will do to anchor at the port is move to the left for few steps and the down of few steps. So the solution will be the number of steps left and down by the ship, or we can use the translation formula. We already know the formula of the translation is x prime, y prime is equal to x, y plus a, b. From the given, we know that x, y is equal to 5,3 and x prime, y prime is -1,0. Then we substitute to the formula of translation and we get -1,0 equal to 5,3 plus a, b. From this formula, we can get to equation. Is the first equation is -1 is equal to 5 plus a, so a is equal to -1 minus 5, and then the value of a equal to -6. We move to second equation, is say that 0 is equal to 3 plus b, then b is equal to 0 minus 3, so the value of b is equal to -3. We rewrite formula of the translation and add the value of a and b we find before. So we rewrite a -1,0 equals to 5,3 plus -6, -3. Therefore, the translation that must be done by the ship is -6, -3. Back again to the illustration that have been drawn. If we use step to calculate the number of steps taken by the ship, we will also get the same result. We agree that a step to the right is positive and a step to the left is negative. Up is positive and down is negative. From the illustration, we know that the ship moved to the left by 6 steps and we get -5. Then the ship moved to 3 steps, moved to down 3 steps, and we get a -3, so the result is the same. So we can conclude that the translation done by the ship is negative.
When the pirate arrived on the island, the pirate spent the night on the island 7 days to conduct business by setting up tent. Coincidentally, the location of the tent in front of him, there is a teak tree. So, every time when the pirate came out from the tent, he saw some fallen thick leaf. You remember, guys, that the island was experiencing summer at the time? Then, if the pirates see the thick tree leaf falling on every morning, how many leaves are there on that tree? In this event, you can use the implementation of arithmetic spans. For the example, we can see on the next problem.
Okay, problem 2. Thick tree will drop their leaves in the summer. This is an adaptation of the thick tree to seasonal changes in the tropics, which aim to defend themselves from adverse environmental pressure. This is due to the role of the hormone abscisic acid. On the first day, Pak Ali found 5 fallen leaves on the thick tree, and then on the second day, Pak Ali found 10 fallen leaves, and on the third day, Pak Ali found 15 fallen leaves, and this is continue until the last day Pak Ali was on the island. He realized that the leaves, that the thick tree had shed all its leaves on that day, and then we can form the number of the fallen thick tree to arithmetic series pattern. So how many leaves on the thick tree? So guys, from the given, we know that the number of fallen leaves forms an arithmetic series for pattern. So the first, for example, the first day will be first term, then u1 is equal to 5. We let it by a, and then for example the second day will be second term, then u2 is equal to 10. The number of days a thick tree sets all its leaves is n, so n is equal to 7. So the ask sum of all, how much sum of all the number of fallen thick leaves, or Sn, and n is equal to 7 because the number of day tree sets all its leaves is 7. First, we will find the difference between each term. So un minus 1, or from the given we know u2 and u1, so u2 minus u1 is equal to 10 minus 5, and it's equal to 5. Then substitute the given to find the number of sum of the number fallen thick leaves. So guys, we know from arithmetic series pattern, Sn is equal to 1/2 times n times a plus un, or we know from the formula of addition, and then we change un is equal to a plus n minus 1 times b, and then we got 1/2n times 2a plus n minus 1 times b. And then we substitute all the given to this form, and then we got 1/2 times 7 times 10 plus 30. Then we got 7 times 20, and then we got 140. So sum of all the number of fallen thick leaves is 140.
Okay, after completing the business on the island, the pirate will sail to the next island. And he said, "See you."